So let's talk about the new cache function in React with example use cases, the concept behind it and what it does and what it doesn't, and actually jumping into the code and applying it so we can see and learn in action. So let's just start with what it is. So cache lets you cache the results of a data fetch or computation. It seems like it's similar to memoization that we used to have in React prior to the cache function. Things like use memo, use callback, or the memo function kind of does the same thing. It memoizes a computation. In the case of those hooks, it's not used for data fetches, but in the case of cache, you can also use it for when you're fetching some data. But it's basically memoizing a computation or a task that's long running and preventing you from doing it again. And that's, in short, what it actually is. It prevents you from calling the same function with the same parameter. So if you have called a function before with the same parameters, it caches the result, whether inside that function you are sending a fetch request or you're computing something heavy. It prevents you or optimizes your app by preventing you from calling that function twice. And this is similar to use callback and use memo. But for those, as I mentioned, we're going to get into the differences in the last part here as well. In those use cases, we would use them for computation and not necessarily for data fetching. Those are when we are using those functions to pass as props, or we want to use those functions as dependencies inside of our use effects. If you're coming from that React background and we don't want the use effect to run unnecessarily or our components to re-render unnecessarily, we would use callback and use memo. This is not for re-rendering per se. It's just used on server components. So I'm trying to draw the contrast between the two. We're going to understand it a bit better, and hopefully by the end you would understand how they're different. So as I mentioned, cache is only for use with React server components. So you would just import this from React and you would call it and pass a function to it. Now, just a quick note that this is different from NextJS's cache. Now, I'm going to have a video about caching in NextJS very soon, so stay tuned for that video. Generally speaking, NextJS has 3-4 layers of different caching in the app router. When we're referring to NextJS cache, we're more talking about long-lived HTTP cache, whereas this React cache, even though the name implies that it is cache, it has nothing to do with cache. It's short-lived, it's per request, and it has nothing to do with other caching layers in NextJS. Hopefully, I'm going to have that video soon on the channel, so definitely check that out. But just a quick note here that this is different from caching in NextJS. It's just a React-specific function that's literally memoizing the result of a function call, preventing you from calling it twice. So let's see the convention of using it. You have to call the cache outside of any components to create a version of the function you're passing to cache, like this calculate metrics here, to return a cached version of that function. Now, it's important to know that you have to call it outside of your components, because if you call it inside of a component, well, it's going to create a new version, a new cached version of that function on every re-render. And then React won't be able to reuse it, or it won't reuse the same function, so it just defeats the purpose. You have to call it outside of your functions. And as I mentioned, cache returns a cached version of the function with the same type signature. It does not call the function in the process. It just saves the result or returns a cached version of that function. When calling the cache function, this is what is returned from calling cache with given arguments. It first checks to see if a cache result exists. If they do, it returns the result. If not, it calls the function and passes the same arguments to the function. Then it stores the result in cache and returns the result. Therefore, the only time that your function is called is when there is a cache miss. Now, as we know, the optimization of caching return values based on inputs is known as memoization. We refer to the function returned from cache as a memoized function. This is what I was referring to when I talked about the hooks that we used to have before, which was purely for memoizing a function. And that's caching the return values based on inputs. Okay, so let's talk about some caveats when we're working with the cache function, and then we're going to see example use cases of this cache function. Now, cache is for using React Server components, so it's for your server side, and it's per request, not for your client side. Cache should be called outside of your component because calling cache inside the component creates a new function for each render, as I mentioned. And instead, you have to define the memoize function in a dedicated module and then import it across components so they can use or refer to the same cached function. Now, cache is short-lived and it's per request, meaning React would invalidate the cache for all memoized functions for each server request. So it just lives in a request-response cycle. Now, it's good to note that each call to cache creates a new function. So it means if you call cache with the same function multiple times, it creates different memoized functions and do not share the same cache. That's why you shouldn't call it inside of the components, because it just creates new versions. Now, this cached function that's returned from cache, it is going to also cache errors. So if the function that you're passing into cache actually throws an error for certain arguments, it will be cached. So if you call that function then with the same arguments, it's just going to return the error from the cache, something to keep in mind. And the last point is that calling a memoized function or the cached function that's returned from calling cache, calling that actual returned function outside of a component will not use the cache. React only provides the cache access to memoized functions inside of a component. So I don't know if we saw it here actually or not. So when you're passing a function to cache, it returns this get metrics. You can only call this inside of a component and use the cache because React only provides this memoized function or the cache through a context which is only accessible from a component. So if you're calling this returned value or returned cached function from a different module that's not inside of a component, it's not going to benefit from the cache. That's the point. Now let's see where can we use this cache function. So examples. By the way, this is just my notes from React documentation. I haven't wrote this. I have just summarized what I learned from React documentation, where you can find it at react.dev. So the first example is cache an expensive computation. So if you're doing something expensive, if you're using it in two components, we're going to pass this to the cache function. It returns this get use metric. So whenever we're calling it with the same user, it is going to actually, I don't know what happened here. So whenever we're calling it with the same argument, it's going to use that cache version. So we're not running this function twice. Again, we're going to see this in action inside of our code because oftentimes we're going to have to call some of the functions twice inside of our React Server component. For example, a use case would be fetching some data for your server component, but actually also fetching that data to generate metadata. So you're sending this request or using this function twice, and we're going to exactly see that in action. So that's number one example. Number two is to share a snapshot of data. Now, let's say we are checking temperatures at a specific point in time, or I don't know, the value of a currency exchange rate. When you are caching the result, it's just at that snapshot. And when you are sharing that result of that function call or fetch call to other components, they all share the data at that same point in time. So that's what's referring to. And the last use case, which is often not even talked about that much, which is a pretty cool use case of the cache function in React, is to help with preloading data and actually making our apps more optimized. I'll try to implement this as well in our application, and hopefully you would understand what this is. But what we are trying to do here is that if we are, let's say inside of our page, we are running, we are rendering this profile component. And inside of our profile component, we are awaiting calling this get user function that's going to give us back the user. Now, when we are rendering the page, we can just initiate this call without awaiting it. It's the same function call. So we initiate this call over here without awaiting it, which is going to trigger that function call and store the result of it inside of our cache. So when we actually get to the profile function, this is going to take less time to resolve compared to when we had not done this. And this will be useful if more stuff is happening in between this function call and you rendering this component. So as you can see here, per the documentation, it says some computational work. So assuming that this page component is also doing other stuff. So it's using the profile, but it's also fetching more components or sending more requests. Initiating this function call is going to start sending that fetch request. It's not going to wait or block the rendering, so it's going to continue. And then when time comes for that component to actually also call that function, the second time, because it was used with the React cache, it's not going to resend or recall that function. It's just going to use the result from it. Now, technically, how it happens is that when rendering the page, the component calls getUser, but note that it doesn't use the return data. This early getUse call kicks off the asynchronous database query that occurs while page is doing other computational work. That's what we mentioned. It's just happening in between there and rendering its children. When rendering profile, actually, we call the getUser again. If the initial getUser call has already returned and cached the user data, when profile asks and waits for this data, it can simply read it from the cache without requiring another remote procedure call. Also, if the initial data request, this function call we initiated here, hasn't been completed and it's in pending, we're going to cache the promise still and use that same promise when we're calling this getUser again in the profile. So whether or not calling this function resolves or it's still a pending promise, we're going to cache either the result or the promise, which is going to result in a reduced delay in data fetching when we actually get to the profile. We're going to also see this in action in the code. But before we do so, as the last point, as I mentioned at the beginning, I want to compare the cache with the memo function and the use memo function, when to use which and how they're different. All mentioned APIs offer memoization, but the difference is what they're intended to memoize, who accesses the cache, and when their cache is invalidated. So they kind of do the same thing, but it's just who is accessing the data and when is this data invalidated. Now, use memo is for caching an expensive computation in a client component across renders. Two key points here. It's for client components and it's for across renders. Whereas our cache function is for server components and it's just in one request cycle. Use memo's cache is local to the client component calling it. You can't use the result of use memo in another component or use it in a module and share it across components. It's just local to that client component calling use memo. Another difference. Cache, on the other hand, is used to memoize work in server components that can be shared across components. And that's the whole point. Not only that component can use it twice if it's using it inside the server component and let's say also in generate metadata function, but you can also share it across components. Cache is also recommended for memoizing data fetches, unlike use memo, which should only be used for computation. So we don't use memo for data fetches. It's just merely defining functions that we usually pass as state updated functions down into props, and we want to memoize them so it prevents re-renders. Or it's that we are, let's say, filtering a humongous array. We don't want to redo this or recompute this expensive computation, and we're memoizing it so we can just use it inside of that local component. Now, at this point, as I mentioned, cache should only be used in server components, and it will be invalidated across server requests. So it lives in a request response cycle, and it's only for server components. Memo, on the other hand, is a function that we use to prevent a component re-rendering if its props are unchanged. So this is not the use memo function, it's the memo function that you would wrap your components with. So if the prop hasn't changed, we don't want to re-render a component, you just wrap it in the memo function. So it's basically preventing a component from re-rendering if the props aren't changed. So it's different in that it memoizes the component function itself, because your components are actually functions with props being their arguments passed to them. So it memoizes the component function or the function component and avoids re-rendering it if the arguments passed to it or the props passed to it hasn't changed. So with this out of the way, let's actually jump into the code and see all of these implementations in action. Now we're going to build this on top of this to-do application we created in previous projects, specifically the optimistic UI video, where we had this to-do app that you can create new to-dos and mark them as complete, all using optimistic UI. So if you haven't watched that video, or if you're interested to know how we built this, you can reference that video. There's going to be a link in the description and also in the cart. I'm not going to dive into the details of implementing this to-do app, but what we're going to try to do is to use the cache function to avoid calling this data fetching twice inside of our component. So let's dive into the app folder. Let's start from our home page. Let me close this off. Inside the home page, we are rendering this section that you can see. I'm calling this get to-dos function. We're going to look at this in a second. This is going to get some to-dos from our database. I'm using Prisma and MongoDB as a database, and then passing it to this to-dos component where it renders the form up top and also this optimistic to-dos down here. Okay. Again, the implementation of this to-dos is in that previous video. Check that out. The link to this source code is also in the description. So if you want to check it out and dive deeper, you can check it out. But here, what I'm trying to demonstrate is that I'm calling this get to-dos function to fetch some to-dos. Oftentimes for your server components, you want to also call this generate metadata function to generate some dynamic metadata. It doesn't make that much sense here because this is just a static page. It's not a dynamic page. And for your static pages, you can just export a metadata function. But if you were calling this function twice, the point is reusing the cache so that we are not doing this database query or fetch call twice. So let's look at this get to-dos function for a second. We are calling prisma.todo.findMany to get all of our to-dos and returning them. Right now, we are not using the cache function, so we want to see this in action. But later on, we're going to introduce a cached version of it and compare the two. Now, from a high level, we are using Prisma to connect to our MongoDB database. We have user and we have to-dos, and we're linking the user to to-dos so a user can have an array of to-dos. So later on, we're going to also go to a specific user page to see the preloading of data using the cache function in action as well. This is the third use case that I mentioned. So let's go back to our page now. If I pop open the console and let's clear the console here so you can see what's happening and pm dev again. So if I go ahead and refresh this page, you would see down in the console log that I get to-dos twice. So I'm calling it once when I am generating metadata, and I'm calling it again inside of the page component. And inside of get to-dos, I'm just logging get to-dos. Okay. So let's change this to, instead of calling it directly, we used a cached version of this function. And the way we're doing it is that we are defining this get to-dos as a const, wrapping an async function inside of this cache function that we got from React. To see this in action, if we go ahead and refresh our page, we should only see one get to-dos because the second time around, as you can see here, the second time around, it actually uses the cached version or the result and doesn't call this twice. So this is optimizing your app by not running heavy computations or database queries or fetching requests twice. Now let's see the second use case, which is even more interesting than this. So let's go to our app again. Inside of the app, I have this users page and a dynamic ID and a page inside of it. And let's see what we're doing here. So inside of this dynamic user ID page, I'm first fetching the user. So I'm calling this get user function. we're going to look at in a second, passing the params.id. This is passed to our page component from Next.js. This is the dynamic ID part here. And based on that ID, we are fetching the user. Now, if we have the user, we're going to render this user component. So let's go to the user component. Inside of the user component, we are passing the user ID to now fetch the to-dos specific to this user. So we're going to call another function, which is get to-dos by user ID and pass the user ID to it. And then we get the to-dos, pass it down to the to-dos component. And this is going to basically do the same thing by rendering the form and the to-dos. So let's go to users and that specific user. Now, one of the to-dos that you saw in the last page is not created by this specific user, so you only see one. And it's showing that user's specific name here with the form and the to-dos. Now, the idea here is if I open the network tab and actually refresh this page, if you scroll up, it took 2 seconds for our initial request to come back and to render our page. Now, let me dive into what's happening here. So the first call that we have is this await to get the user. This is going to call Prisma to get the user with this specific ID. Now, I've imported this delay function here. This is just basically delaying this task by 1 second. And then once we have the user back, if we do have, we're going to render the user. And inside of this user component, we're doing another call, which is another database query using Prisma to then now fetch the to-dos for this specific or where this user ID is this ID for this user, which means this second database query doesn't happen until this is already finished, where we render this component, and then we get to this point and then initiate this database query. So it creates a waterfall of us fetching some data, rendering a component. That component needs another data and sends another database query, and then renders the result on the page. Now, how can we avoid this? By using the cache function to preload this data instead of having it to waterfall one on top of the other. So if I go back inside of my page, and right here, I'm going to initiate this get to-dos by ID, and I'm going to pass in this params.id. Again, note that I'm not awaiting this call, so I'm not blocking the render. I'm just initiating this second database query call that only happens inside of this user component. And right now, we're not using the cache, so this shouldn't make any difference. So if I refresh the page right now, even though I have initiated this function call before I actually get to the user component, if I scroll up, it is still taking 2 seconds to respond. Now, let's go to this functions where we are using this to-dos. And now, instead of just using this get to-do by ID function, I'm going to comment this out and bring in a cached version of this component. So this is, again, using the cache by wrapping this async function, which is basically doing the same thing, finding to-dos where the user ID is this user ID, and I'm exporting the same name. I'm just passing it to the React cache function. So this time around, when this page calls this function without awaiting it, the result of this function call is going to be cached. And now when we get down to this user component where we actually need to use this result or await the result of this function call, we're going to use the cache. So with this, let's just refresh. And this time, if I scroll up, it only took 1 second and 19 milliseconds to render. So we have reduced this process or optimized our app by 1 second. Now, obviously, I have exaggerated this delays here with this 1 second delays that I'm passing, but you get the idea. Because we initiated or preloaded this data ahead of time or initiated it before we actually needed to await it inside of this user component, it was cached or started sooner. By the time we got to this user component, we already had the result. It's either the promise that we have cached, if it hasn't been resolved, and if it was a longer process, we're going to use the same promise. And if it has already been resolved, we're going to use the data, and we don't have to initiate this call again, which you can see, obviously, it's going to make our app more performant by avoiding the waterfall of this request to happen one after the other and initiate them kind of at the same time and use the result in the cache when we actually get to that component later on. And that's a wrap for this video, folks. I hope you learned the new cache function in React and how you can use it or benefit from it, whether it's caching or memoizing the result of a fetch request or a heavy computation, or actually using it to preload the data, just like the last example that we see, and how it will be different, or it is different, from caching layers in Next.js, which hopefully we're going to cover in another video later on the channel. So stay tuned for that. If you have any questions, like always, hit me up in the comments, and I'll see you in the next one. Bye-bye.